Okay, all right, so this is really important. It shows the difference between a natural drainage basin and an urbanized drainage basin. Okay, I've put down here that exam questions like this come up all the time. Okay, all the time. It's going to be repeated so much that understanding the hydrological cycle in a drainage basin and saying what happens before urbanization, after urbanization is really important. So I've just put two pictures in here just to help. So this is supposed to represent a natural river drainage basin. So we've got the river down here, okay? And then you can see there's no buildings, nothing's been done to this landscape. It's totally natural. And then this one here, and again, there's no farmland in here. That's also important as well. Okay, this, there would be a river somewhere in there, and you can see that it's totally urbanized and a city has been built, okay? So this is a storm hydrograph before urbanization, and we have this long lead time between the rain event and the peak discharge, whereas in this one we have a short lead time between the rain event and the peak discharge. Okay, we can also see that the peak discharge is much higher after urbanization than it would be with the same rain before urbanization. So basically what this is showing is the flood occurs faster and is much worse in an urbanized drainage basin. All right, so what reasons are this? Okay, so you need to explain what the differences are. So what I want you to say down here is you need to say that there is a steeper rising limb and a more steady falling limb, whereas you can see that it's a quicker falling limb before urbanization. Okay, and I want you to say that there is a higher peak discharge after urbanization and a lower peak discharge before urbanization. So let's look at these two pictures. Why is that then? Why? So if there's the same rain event here, the flood is nowhere near as bad as if you have the same rain event here. Okay, so precipitation falls from the sky in both these places. As it hits the ground, it might not hit the ground straight away. It might hit these trees, okay, which means it gets intercepted, and then it slowly makes its way down to the ground through stem flow. Okay, so you have precipitation, interception, stem flow, and therefore it doesn't get to the ground to surface storage as quickly. Whereas in this area, there are no trees, so the rain falls directly down onto the impermeable surfaces, okay, and starts to pool as surface storage straight away. Now, once it does reach the ground here, it might infiltrate into the soil, so the soil will suck up a lot of the precipitation. In here, we've got these impermeable tarmac, impermeable concrete, so it doesn't infiltrate. It sits on the surface and starts to build up to then flood. So a lot of the water here might infiltrate into the ground, and if you've got a very porous bedrock with a low water table, then it might percolate all the way down to the groundwater very quickly, and that leaves less water to flood on the surface. Okay, once the bedrock and the soil are saturated and no more water can enter it, then you'll start to get more pooling on the surface. Or if the precipitation rate is higher than the infiltration rate, then you will get some pooling on the surface, but it will still get a lot will be sucked into the soil. Here, nothing is sucked into the soil. It sits on top and starts to flood. Okay, so as soon as it's on top of these surfaces, it flows very quickly over this concrete and over this tarmac, and then it flows right into the river channel quickly because it's flowing through overland flow. Okay, whereas this might be flowing through overland flow, but mostly through flow and maybe even groundwater flow to get to the river channel. So which is much slower, which means the peak of the floods happens much later. Whereas here, all the water rushes over all the tarmac and concrete straight into the river channel, and so you get this fast rising limb of the amount of water in the channel rises quickly, and then it peaks higher because all that water gets into the channel quickly, so the amount of water is higher in the river. Okay, whereas in the vegetated drainage basin, that water that gets into the channel earlier will flow down the channel and out to sea or further down the river, and then the water that's been stuck in the soil and in the ground makes its way into the river, so you get this long peak, okay, but it never is as high as the urbanized peak, okay, and there are lots of ways a drainage basin can be modified to increase the amount of surface runoff. So if this area was turned into farmland and all these trees were cut down, there's going to be less interception, and the rainfall might infiltrate into the soil, true, but there'll be less interception, so no stem flow, so that then increases the rate at which water will get into the river channel. Not quite as fast as an urbanized area like this, but a farmed area will have a higher peak discharge than a natural area, okay? Right, so this is what you need to do. You need to explain the differences between the shapes on these two graphs. All right, good luck.